Okay, net zero shipping. Can it be done? This year, the global fleet emitted more CO2 than in any year in history. Last year also more than in any year in history. Next year will probably also be the same. And yet the target that we all have and that the IMO has set is to get to net zero by 2050 and to get 20% below the 2008 levels by 2030. So we're here today to discuss, can this be done and how? And we've assembled for you the best panel of experts on this topic I can think of, from diverse parts of the shipping industry and of the broader energy world. We have Stamatis Tsantanis from Synergy. Synergy is a, I would say, startup shipping company. It started very recently with just one vessel, now up to 20, and has been very, very progressive in its digitalization and decarbonization. Can you hear me? Yeah, yeah. Mainly bulk carriers. We have Katerina Vdroglu from STEM Shipping, also in the bulk carrier sector. In Greece, facing in a type of shipping industry, type of shipping company that faces one of the strongest decarbonization challenges, but making a lot of interesting steps. And we have Andreas Enger from Hogue Autoliners, a Norwegian car company, and we're going to hear now about some of the incredible things that they're doing, not just for the short term, but also for the very long term targets. Just for the audience, because not everyone's familiar with shipping, bulk carriers, those are ships that carry bulk cargo like grains and coal. Autoliners carry cars. It's very simple. And then we also have representing the Ministry of Energy, Vasilis Triadaphilos, who's a lawyer and energy transition expert, to give us the broader view from the energy sector. So I'm going to dive straight in with the question. Okay, let's start with the 2050 net zero target for shipping. Is it realistic? Yes or no? Show of hands. Who thinks it's realistic? Okay. You can just do, yeah, you can do this if you want. Okay, great. 2030, 20%. Okay, so everyone is optimistic except our lawyer who is hedging. So that's very good. Andreas, your company appears to not only be optimistic, but to think the 2050 target is even not ambitious enough, because you've set yourself a 2040 net zero target. Do you want to talk to us about that? Why you've done that?
Yes, I can comment briefly on that,
Yeah.
but I think it starts with the fact that we're already today almost 40% below 28 on a unit basis, and we're looking at another 30% by 2030. But I want to sort of also deal, we have a fleet age structure. That means that all our older vessels that are difficult to convert to new fuels will be out of our fleet by 2040. We have some new vessels that we know we can convert to methanol, and we're making all our new builds, multi-fuel, zero-carbon fuel ready. So I mean, it's driven by our fleet profile, but we believe that is entirely possible. And also one reason it's possible is because we serve a industry that is going electric on their products, going renewable on their factories, are sourcing green steel and aluminium, and it's probably the most carbon conscious shippers in the world. So,
right.
So I think we need to have the context. So we're saying that's possible for us. We're not arguing it's possible for the industry.
Yeah. Okay. But you do think it's possible for the industry, though.
2050 is
yeah,
possible for the industry. 2040 is possible for a few players that have the right customers and the right fleet composition.
Okay. So you raise an interesting point about the fleet composition in terms of age, right? Because obviously new builds, you can make them much more carbon efficient than existing ships. So Katerina, do you want to comment on how do you strike a balance between investing in the decarbonization of your existing ships versus new builds?
I mean, I'm definitely the wrong person to ask about new builds because, you know, it's a bit like asking your Uber driver what the fuel of the future will be. I don't know, frankly. We don't have a new building program. But as ship owners, we have a long tradition of kind of adopting new technology and adapting to systemic change. But it's usually the case that the new technology is provided to us by the shipyards or the engine manufacturers or the disruptors like yourself. So until then, we're kind of waiting around for the Henry Ford or the Elon Musk of shipping to guide us in the right direction.
Okay. So what are you waiting to see in order to conclude that, for example, an alternative fuel or some other technology is
I mean,
viable?
with bulkers, I don't think many people are ordering dual fuel bulkers at
Yeah.
the moment. We're waiting for the groundbreaking design. I don't know if Samatis agrees with this.
Yeah, Stamati?
Well, sure. I mean, neither do we have a new building program, and we don't really believe right now that the solution, as far as dry bulk is concerned, is in the invention of the fuel of tomorrow, because no such thing has really been applied as the proven solution of the future. So what we have done since 2015 is that we have invested heavily on our ships to install energy-saving devices, digital equipment that help us assess, how much we're burning and how much we can make it more efficient, more optimized. And that's what we do. I mean, at the end of the day, dry bulk, and especially the bigger ships in particular, like we own, the Cape sizes, we transport iron ore and coal. So we're in Dubai right now, in Dubai, Abu Dhabi area. When you see all these high rises and all these steel works, you need steel in order to build all this infrastructure. And unfortunately, whether we like it or not, dry bulk shipping will be a big contributor in all this infrastructure drive of the world for the next 20, 30 years. So it's kind of a paradox to talk about alternative fuels when the cargoes that we're transporting are a mandatory part of, the chain of development for the world, for the Earth, over the next 20, 30 years. So yeah, we're trying to make the ships more efficient, but at the same time, the carbon impact of all this development globally, unfortunately, is kind of uneven. So that's the thing.
But you have invested in biofuels, right? So why are those special compared to the other fuels you say are not proven yet?
Well, biofuels is something that originated, to be honest, from our clients. And we have co-developed with our clients a number of solutions for the ships. And we were asked almost 3 years ago to start testing biofuels on some of our ships. And we did a very careful analysis in approaching, the engine manufacturers, the insurers, and everybody associated. Because when you test a new fuel on board the ship, which is basically 10 years old, you don't want to be stranded in the middle of nowhere, on a dead ship or anything like that. So we did all the right measures. We tested it in the summer of 2021. We were the first company to test it on a Cape-size vessel globally. And we're very happy with the result. And we tend to use it whenever biofuel is available, cheaply available, and it has a competitive advantage over the emissions of the standard fuel. So we do it. There's no sufficient capacity of biofuel globally right now. We hope that there will be in the future. We hope it will be one of the key fuels of tomorrow, biofuels, methanol and all that, and ammonia, of course. It's just that we need quantity. We're still very low on quantity of all these alternative fuels, and we need to make that standardized, available and safe. So biofuel is still a very expensive solution, a temporary expensive solution, and we hope that in the future we will be able to see ample quantities to make it work.
Thank you. Katarina, are you tempted by biofuels?
Not for now. No. I think in the meantime, something that we should talk about is operational efficiency, right?
Yeah, we'll get to that.
Yeah.
But just to keep going on alternative fuels, I want to turn over to Andreas to talk to us about ammonia. Ammonia is probably the biggest name in alternative fuels that we talk about. You're actually making it a reality on real vessels. So do you want to talk to us about that?
Yes. No, I mean, we have, based on what we've been doing, we started by being, we needed new vessels, so we had to have new builds. Our fleet was sort of 16, 17 years old, so we either had to build or go out of business, right? And then we had to think about something that can be sustainable in a 30-year perspective. And because our car carriers last for 30 years. And we basically decided that we cannot bet against zero carbon fuels in a 20-year capex decision. So we made those vessels ammonia ready, methanol ready, all of that. And we've had all those optionalities. We started working commercially with our customers, and how do we make the most out of those options, right? And with the car manufacturers, that has been about, introducing zero carbon fuels. And then we started working with Yara, which is one of the largest ammonia producer and trader in the world. Started working closely with MAN. And now we are at a situation where we actually have confirmed slots to get ammonia engines into our vessels in 2027. And we do that because we believe that, but just to keep, we're not able to commercially bet against fossil fuels either. So all of these vessels will be dual fuel, and they will have full endurance on LSFO as well. So I mean, we're not betting that it's not going to be changed to ammonia in 2027. But we believe there will be uptake. We believe having that optionality is important for our cargo owners, and we believe being first mover in our industry is a good thing to do. But we could not do it without optionality. We could not do it without having dual fuel capability.
So how big is the risk you're actually taking when you invest in a dual fuel ship rather than a traditional?
I mean, with how we have arranged our new build program is pretty low. I mean, the biggest risk is that we have basically built dual fuel LNG capacity that have added some cost to the engines.
Yeah.
But that we believe is usable, and then we had the benefit of actually being early in ordering vessels. So I think we have cheaper vessels than most of our competitors, even if we have more fuel optionality, which is really what we're now trying to leverage by using that optionality as forcefully as we can commercially.
Sure. And so what are the things, in order for ammonia to be successful, what are the things that you need on the land, as it were, in order for this bet to pay off?
And again, that's a bit difficult to the bulkers, right? We're a liner shipment, and as long as we use it in dual fuel mode, and as long as only a few customers that we're going to sell zero carbon and normal carbon services on the same vessels because we have multiple customers, right? So maybe it's some high-end cars, 20% of the cargo wanting to buy 20%. I mean, so we run 20% of the voyage, right? So we, to make it very, very simple, if we can bunker ammonia one place in the world, and we're calling on Australia, we are passing Singapore, we're calling on Japan, we're calling on the US East Coast, we're calling on Northwest Europe, we can start using it. So that's also very different from actually being in sort of tramp or not knowing exactly. We run fixed routes around the world, and with dual fuel, we don't have to bunker and use the fuel at the same place, right? So you have to get all of these nitty-gritty details, because we know, like everybody else, that this industry is not going to change to ammonia-fueled vessels 100% in 2028.
Yeah. So just to explain this for people, then you're investing in many people in the shipping industry that are in parts where they're able to be more flexible, are investing in these dual fuel engines. They can use ammonia, but they can also not use ammonia. In order for the entire industry to be able to use ammonia, you need an infrastructure in place. So what does that look like? You need terminals?
Yeah, but then you need a fueling infrastructure, and I think it's. I mean, we don't particularly care whether that is 5 or 10 or 15 or 20 years out, because there is enough infrastructure actually almost already, or will be in 2027 for us, it would not have been sufficient infrastructure if everybody did the same as we did. So I mean, it's just I think the important part is that we have decided to take these steps. We are able to organize our trades and our fueling and everything in a way that works for us. We understand that this is not the solution for everybody, but for premium electric cars produced carbon neutral and with the brand position of being carbon free throughout the value chain, this is an offering that we think we can sell in the market.
Great. Okay, so this brings me over to Vasilis. So large parts of the shipping industry are planning for ammonia. They're depending on a land-based infrastructure. Will this infrastructure materialize, and are people aware of the needs of shipping when they're doing this planning?
This is exactly the reason why I didn't answer enthusiastically in the affirmative in your first question. If it was a question about shipping alone, then yes, we could say that yes, it can be done, it will be done, it must be done. Shipping can and will be decarbonized by 2050. But it's not just about shipping. There's a whole, a lot of other sectors are involved, predominantly the energy sector, but also infrastructure, ports and all that, that need to synchronize their investment priorities, synchronize their policies, synchronize the incentives or the market signals they give in order for a whole supply chain to materialize so that shipping can decarbonize. So from our end, from the energy sector end, I mean, you can order a ship to use, I don't know, whatever alternative fuel and get it delivered in what, 2 years? In order for us to build a power plant that produces hydrogen, green hydrogen from renewables, we need a minimum of 7 to 8 years. So, I mean, who's waiting for whom? Do we build the plants and wait for you to get the ships ready? Do you start building the ships so you can offtake our fuels? The me and you is figurative, of course, right? So between the two sectors. So this is the in my eyes, this is the main question we need to address, we need to answer. How do we synchronize the various parts of the supply chain that need to materialize in order to actually be able to do it? The technologies are there, but the technologies need to be somehow de-risked and incentivized so the costs drop and it makes it, I mean, reasonable for everyone. We need to spend money on hydrogen to bring the price down. We know how to do it. We've done it with solar PV in the past. We've done it with wind power in the past. We're doing it right now with offshore wind, incentivizing investments, bringing the cost of equipment down, and then getting a very low levelized cost of the final product of electricity. We can do the same for hydrogen. But we need to know which fuel we will select. We need to talk. So basically, the answer, coming back to your original question, as well as the discussion on alternative fuels, is it can be done as long as we work together, we collaborate, and we synchronize our priorities so that we're all walking down the same path.
Great. Okay, so let's now move more to the 2030 target. Okay, we need to go 20% down as an industry from when we're in 2008. You know, you've already achieved this, I understand, but you know, you're going to go even further. So what can be done now with existing ships to make them more efficient and to reduce their CO2 impact? Andreas.
Yeah, no, I mean, I think, as you said, my main argument is that I think we should not say that this is one or the other. It's multiple things are going, and there's going to be a lot of synchronization going to get the whole industry along. But I think in our sort of strategies, we have basically two main pillars. We are ambitious on decarbonization, but we're also putting a lot of focus into digitalization, because with the connectivity of vessels, with better measurement, and also actually with new builds, the opportunities to optimize existing operations, as we said, is important. And for us, wanting to move rapidly to alternative zero carbon fuels. Let's face it, those fuels are a lot more expensive. So, the operational efficiency is getting more important, not less important with new fuels. It's just changing a bit from carbon to cost. So we are committed to, do everything we can to operational efficiency. We are embracing the digital solutions, the AI tools, the we've been doing weather routing and forever, but it was done on weather reports and noon reports and manually, right? And you just get so far. And the technological development, the connectivity of vessels, the data power, and the algorithms that you provide, obviously allows for that S-curve, which is important to reduce carbon footprint before we get zero carbon fuels, and it's important to reduce the cost of using zero carbon fuels when they get there. So I don't see any trade-off at all, and it's incredibly important.
Great. Katarina?
Yeah, I think operational efficiency gives us so much space for improvement and can actually really help tackle maritime emissions. I don't know much about car carriers. What's the average speed that you sail at?
60.
So speed's
So
a
can
huge...
you just repeat that because it wasn't in the
16
mic?
knots.
16 knots.
Okay.
It used to be 19.
Exactly. So, I mean, with regards to speed, as you know, by increasing a vessel's speed from, say, Rotterdam to Piraeus by 20%, you have a 44% increase in emissions. Technology and energy-saving devices are great, but they usually lead to a single-digit saving. Whereas by curbing our speed, we can actually make a huge immediate change to shipping's, maritime emissions. And there are steps made in the right direction. So EPL, I think, is kind of promising, but in my opinion, it's way too timid. We need something that's much more widespread and much more decisive.
Right.
And
But this comes at a cost to you, right, commercially, if you go slower.
I think the planet can afford to slow down, and there are many proponents of that argument, right? And the second element, which would make a huge difference, and you know this very well because you built a tech company on this premise, is hull performance, right? And as my dad, who's a naval engineer, has successfully brainwashed me to say, for every 100 microns of roughness, you get a 10% increase in your emissions. That's huge. Yeah. So, and obviously, like, sensors can help, underwater cleaning can help, new coatings can help, but there's nothing that returns the hull to its original smoothness. Yeah. Think of Michael Phelps in a supersuit versus Michael Phelps covered in barnacles, struggling to swim through warm water, right? So the best way to prevent hull fouling in the first place is to tackle vessel idleness. Stamatis and I both know that we often end up having ships waiting around in, say, a Brazilian warm water port for 30 days. By the end of the 30th day, these ships are covered in evil barnacles that affect their speed and therefore their environmental efficiency. So it seems to me that the easiest way for the IMO to help reduce our global emissions would be to say that, okay, after a certain number of days, you have to move around within the vicinity. This would obviously mean that we'd have to change port regulations, we'd have to negotiate our charter parties a bit, we'd have to perhaps amend insurance cover, but you would have an immediate saving. I think what I'm trying to say is that efficiency has a lot of nitty-gritty and a lot of regulation. It's not as sexy as ammonia, but it could help us save the planet, and it could do so with immediate effect.
Okay, that's very interesting. So I think both of the things you mentioned, both the, sorry, I'm going to ask you a quick follow-up. Yeah, both of the things you mentioned, both the speed limitation and the idleness require basically imposition from the state, right, or global institutions. Yeah, okay. Is there anything you think, in terms of efficiency, that the industry could be doing on its own?
Better monitoring, yes, and then all of these different technologies can be tested in dry docks. The literature varies. We haven't found anything that leads to huge savings. But I think just having a better understanding of the performance can lead to immense, immediate positive effects, right?
Okay, thank you. Stamatis.
Well, thank you. As you know, we have been one of the first movers in applying digital solutions on the ships, and we have been using the DeepSea, which we believe is one of the most advanced tools you can use globally for knowing what the vessel can do, and the AI spin of that can actually help understanding not just the optimization, the efficiency, but also preventive maintenance, which is also a huge element. Going back to the investment on the existing ships, I kind of disagree on certain aspects, because we have been using pretty much everything that is available on older ships since 2018, so we are now entering our 6th year in investments on the existing vessels, and having tested almost everything, again, everything you can do on existing ships, we have found recently that applying the new paints, the new coatings, especially the new silicone-based ones, can have a massive improvement on the efficiency of the vessel. I mean, on a recent case, we recoated a 2006 Capesize, I mean, like 2 months ago, and we are seeing benefits reaching 20% reduction in consumption and improvement of emission. 20% just by the coating. Of course, it's a very painstaking exercise, because you actually reskin your ship. You have to apply it down to the bare metal, the whole thing, and then recoat the vessel. So it's a very expensive exercise. But in my opinion, nothing compares out of all the existing solutions to the effect of the new coatings, the self-cleaning of that. We have one ship that after 1 year of the application of the new coatings, the actual disintegration has been 1.5%. It's nothing, even though the ship, enters and stays in ports. But I also echo what Katerina said about the efficiency and the speed. The global fleet needs to slow down. It's a myth that the vessels are going slower. The deadweight adjusted speed is actually much higher, and that needs to change. So if I were to do something immediately imposed by governments on the vessel, was a very severe scrutiny on speeds and efficiencies. You cannot speed up a vessel transporting iron ore and coal, which I cannot say it's a very sensitive commodity. It's rocks, moving with 14 or 15 knots to go from Brazil to China and the way back, just to be waiting in Brazilian waters or in Chinese waters for a month to load or discharge. That's wrong, and we should definitely do something to change that.
Andreas, you want to say something on that?
Yeah, I also just want to echo that, and as you said with DeepSea, the benefits of being able to do better voyage planning is a great thing. I think another great thing is to create more transparency about what we're talking about now, because if you look at what ports are eager to put in electric trucks and maybe the truck lifts and maybe some shore power and stuff, but if you look at their actual contribution to the carbon footprint, that is, first it's the additional speed. You basically have to just to wait to keep your place in the queue. It's about the deterioration of the hull condition while you're waiting, and all of these kinds of things. And it's the cost of the waiting. So the getting transparency around what is the actual source of carbon emissions and costs in the industry. And I think you will find on that the need to actually digitize and improve the port operations is a lot more than electrifying the import operations.
Yeah. So see, this is a good question. So in terms of the idleness problem that you've all mentioned one way or another, right? How much of that needs to be fixed by government regulation, and how much just requires more digital platforms for better coordination between the port and the ship owner and the charter? And
I don't know, but can I sort of try and answer?
Yes.
I mean, what I said, I think, and where actually the digitalization can work, I think to make this happen, we need much more transparency, and we need much more focus on what is the cost and impact, and that's the digital part. And I think if we get those facts out in the public, this is so embarrassing that it will enforce ports
Right.
operators and governments and regulators to work. But I think it's much easier to start working on the transparency side of this, which we as ship owners actually can do with the right digital tools, and use that to build pressure rather than going into endless sort of regulatory and government discussions that are slow and challenging.
Got it. So, Katarina, in terms of regulations, so you've said we need to slow down the fleet, okay? In theory, we now have various types of carbon pricing or carbon limitations with CII, and of course with the inclusion of shipping in the EU exchange emissions trading scheme. Do you think that these measures are sufficient to get the fleet to slow down, or do you need more targeted intervention?
Which measures are you
So
referring
let's
to?
talk about, for example, the inclusion of shipping in the ETS.
EU ETS?
EU ETS, yeah.
Yeah. Can I just, before that,
Oh, sure,
I think
of course, yeah.
please publish a paper as DeepSea on like the contribution of port stays to global maritime emissions, and then we can send it to some governments. Yeah. With regards to EU ETS, I think it's the perfect example of the politics of good intentions with bad unintended consequences.
Okay.
I really disagree with it for at least 3 or 4 reasons. The first reason is that I think it's structured in a way that will enable policy evasion. The second reason is I think
Why?
because it's so complicated, the way that you report and the way that it comes into force with gradual reporting from
Right.
2025 to 20. You report on 24 and then 2026 on 20. It's a mess.
Do you think also the fact that the MRV reports are based on
it's
noon
a
reports
mess.
is part of the
Completely.
problem?
It's like
Yeah.
a consultant's dream and an owner's nightmare. So I think that the EU should basically refrain from regulating what's truly a global industry. I think it should instead focus on lobbying the IMO, providing research, providing guidelines, because by doing so, by coming up with all of these regulations, it just ends up undermining the IMO's role. So that's the first reason I disagree with it. The second is that I think it's going to end up negatively impacting intra-EU and extra-EU trade, and it's going to negatively impact European ports. I recently read a very interesting report comparing Algeciras in Spain to Tangier in Morocco as container transshipment ports.
Yeah.
And the study found that the relocation to Morocco would make sense with a carbon tax as low as €6 per metric ton. And I think it's currently trading at what, 80? Yeah. So, and the third reason, and this is a more kind of political argument, is that I think the EU should finally acknowledge the importance of European shipping and of preserving its maritime independence.
Okay. Yeah.
Yeah. If I can add to that, the only way that you can have some sort of a, going back actually, there's a big fragmentation of interests. I'm not going to say conflict of interest, but there's a big fragmentation of interest. So when someone expects a product delivered to its home, he doesn't have the awareness of the environmental impact if there's no cost associated to that. So the EU ETS, it's an indirect way to provide awareness to the overall exercise of logistics when we need to transport things as to how much it costs, for the carbon impact of that. So I'm not completely against the EU ETS. I believe it's an indirect way to create this awareness, because when a trader sells grains from Argentina to China, the least priority in his mind is the environmental impact of the transportation of those grains to the other side of the world. But if you create a cost, then automatically, you impose awareness. It's not the right thing to do, but the actual trader or the actual receiver is completely disassociated from what's required, in respect of transportation. So I'm not completely against that, to be honest.
Yes, sure.
We know that a carbon tax works, right? And there
Yeah.
are many examples. For example, if you tax gasoline, you'll end up with fewer users of SUVs. We know that. I just think that it should be implemented on an international level and not on a European level.
So, but for example, so you mentioned the case of these trans-shipment, which this is obviously an instance where there's a competitor right next to it who can just take the
Yeah.
business. But if you're importing something, for example, cars into Europe, right? Those will come anyway, surely. So there are examples of trades where putting a price on it will not deter the trade. Isn't that right?
Yes, but then you need to also compare the instance of, say, importing a fridge locally from an EU port to an EU port versus from a non-EU port to a European port.
Oh, I see.
So if they're taxed differently, right? And
Right,
one
so
could
it'll
argue that it's...
discourage intra-EU trade.
Yeah.
Okay, interesting. Yeah, sorry, Vasily, you wanted to... Yeah.
Just 2 words on the ETS question and
Yeah.
how EU approaches the sector. First of all, these are my personal thoughts, in no way reflecting what the ministry's stance is on things. But what you mentioned about how the EU should refrain from actually regulating what is an international sector brings me back to my early days as a shipping lawyer about 25 years ago, when there was this whole question about port state control and flag state control and how we should approach it. EU was actually one of the first jurisdictions to militantly approach port state control and try to get what the EU thinks is right, apply in their ports, regardless of the flag of the ship. So we're seeing basically a repetition of this motif, of this approach now with ETS. They're trying basically to regulate in their own home waters what is an international issue. So it's not a new question. Now ETS is, I know it's scary. I know it's scary because we've been working with ETS for many years in the power sector and other sectors as well. We know it's expensive, but we also know it works. It works, what you mentioned, it works to actually put a price on the impact of the commodity you're selling or you're buying or you're utilizing. I'm not saying the EU approach is fully, let's say, very well designed. I love your comment about how it's a consultant's dream. Being a consultant myself, I love it. I love how complicated and how convoluted it is because I can actually bill man hours explaining it to people. But yeah, still, it's for me it's a manifestation of the European Union's will to actually do something about it. And this is how, I mean, there will be there will be chances in the future to actually revisit the approach, to actually revisit, rethink, optimize, improve. But still, what we jointly, meaning both the energy environment people as well as the shipping people, should get out of this is that EU has decided to actually do something about it. And this is a very clear signal, and it can be, I mean, I know it's, as I said, I know it's scary, but it can also be a force for good. It can be a catalyst to actually bring about what I was talking about earlier, to bring all the forces together to work towards that same goal. And I mean, for me, it definitely has conceptually some merits. Now, the practical applications could be a subject of, I don't know, a few independent panels for the next COP, if you will. But yeah, in principle, it's something that...
Andreas, what's your take on ETS?
No, I mean, I think we'll start by concluding here that this is complicated, right? Because, you know, we're all running commercial businesses, different things. And, you know, we are, as you said, we're shipping cargo, very distinct cargo directly in and out of Europe. And we are investing in zero carbon capabilities. So carbon pricing is obviously a fantastic thing for us. And EU is even saying that you're going to use the proceeds to stimulate zero carbon fuels, which is even greater, right? But then I also agree that, you know, of course this should be a global system managed by IMO. And I fully understand that based on where you are, we see the benefits of ETS to our business strategy. So we basically think it's a good intermediate step. And if you see all the complexities, you say that we should probably wait until we get it global. So we like ETS, and we like the EU signals on the use of proceeds because it supports our business. Ultimately, I think, as you said, is putting a price on carbon is important if as long as we recognize that global warming is a problem, right? So that is important. The shipping industry benefits greatly from having the important stuff regulated globally through the IMO, rather than a sort of. So I think we agree on where, and I think the sort of short-term things will be.
Is the IMO doing a good job?
I mean, I think no, but I think IMO, right? The great thing about IMO is that when they agree and when they get regulations in place, it's effective, right? The downside of IMO, it's lots of parties, and it's a very complex process. And I think, the recent sort of ambitions on decarbonization and stuff, at least from our perspective, they've gone further and faster than we thought a year ago, and that is good. But it's complicated.
So we've talked about the IMO and the EU. If we go one level down to national governments, right? Greece and Norway are both small countries, but which both have outsized shipping industries inside them. What can a national government do to support the transition of its shipping industry?
I mean, I don't think the national government should do much more than, I think one thing is very important for us. We are Norwegian flagged in Norway. We can only be that as long as the Norwegian government and regulations and taxes creates a level playing field. That is the most important one. But we're also saying that obviously with us, with our carbon ambitions, we will have to have a level playing field also on. One of the biggest challenges we have with Norway is sort of fairly ambitious on domestic carbon reductions now, stepping that up. But they're then focusing all the energy on ferries and small things that globally makes up less than 10% of the footprint, while a Norwegian-based company that uses our capital and technology and knowledge to decarbonize globally sort of falls outside. So there is something around the sort of very nationalistic, reduction targets that is not very conducive to stimulating taking down the global sources.
Makes sense. Thank you. Does anyone want to add something on that, or we can go to questions? No. Okay. Thank you very much. So we're now going to the audience questions. So how does it work with the microphones? Can someone? Thanks.
Thank you. Thank you, Eli Mitchell-Larsen from Carbon Gap. I wanted to ask about another kind of out there approach, which is non-stationary point source capture, so carbon capture on ships. There's a few companies like Seabound and others who are looking at this. Of course, it's another activity that necessitates having an offtake and an infrastructure to take the CO2 off, maybe in a place like Portos. But how do you see that working and enabling the use of other fuels? Particularly if they utilize biomass, there's also a possibility to generate carbon removal, of course, if you could then store that CO2 permanently, perhaps in the Northern Lights project.
Well, that's a great question. We are in contact with 2 companies right now, providing solutions for carbon capture. It's not as easy as it sounds, because how do you dispose of, whatever you need to dispose? There are port facilities right now in Rotterdam that you can dispose the carbon captured and the liquid associated with that. We're waiting for Singapore, which is the biggest global bunkering hub, to have those facilities as well. The solution is developing slowly, but you shouldn't expect more than about 10, maximum 20% of the total CO2 emissions to be captured and sold. And that's, on the very high side. Let's start with 5 to 10% to see how it works and how we can store it safely on board. There are solutions in the forepeak, in plastic containers, in a number of ideas, but is not yet ready, is not yet developed. It will be over the next few years. There are various drawbacks into the overall equation, but I'm confident that within 2025, we will have a lot of proven solutions to do that. Again, don't expect more than, let's say, 10, 15% on the very, very high side of carbon capturing, and that's an optimistic scenario.
Since you mentioned Northern Lights, I just want to also pitch our own, the Greek carbon storage facility, which is being developed as we speak in Prinos, in South Kavala, in the north part. It is? What? Oh, the video was playing. Yeah, it's a very it's an innovative project developed in in the sea, northern Aegean, south of Kavala, and CCS is definitely a solution for a number of hard-to-abate sectors. We basically target industrial processes, but also other sectors as well, and it could be under certain circumstances also an answer for the shipping industry. And I don't think we should just disregard it. It should be included in the conversation. It should be examined closely. It's early stage technology at this point, but it could provide an answer in the midterm future.
Yeah, we've seen how, for example, 3D printing has gone from plastics, but then metals, steel, ceramics, and I think that this is going to be a technological advancement that will significantly reduce supply chain emissions, because I'll be able to manufacture and produce at the location and in the quantities on demand. So are you aware of any quantitative assessment of how this will, for example, significantly reduce the miles traveled in the shipping industry overall?
Thank you. No 3D printing involved, but I imagine it might affect some containerized trade, but I don't expect it to have a huge impact. Also, especially when you compare it to like population growth and consumer demand.
Yeah, so also, I mean, all quantitative analysis I've seen just assumes that the volume of trade by ship will have to increase and increase and increase. And because shipping is still, and we should say this, the greenest form of transport, right? It's only going to go up, right? I don't think we can hope that it will go down as a way of decarbonizing. Next question? Yeah.
Hello, Kai Yuan from the Norwegian Ship Owners Association. Very interesting to hear the differing opinions on the EU ETS. I'm wondering if we just take that as a given, it will create government revenues, which are supposed to be reinvested into the green transition. So in the opinions of this panel, how do you think that money should be spent? Thank you.
Okay. Who wants to go first? Okay, let's go around. I'm going to say on AI and digitalization.
Well, I must say that additional electrification, subsidies on energy, I mean, the reason why we're doing that is to have subsidies on cleaner energy, which again, subsidies is not necessarily a positive word, but I would use the Green Fund to subsidize more and more green projects in Europe, more and more energy for the poorer nations. The recent military conflict with Ukraine and Russia increased the energy prices for the European households very significantly. And I would like to see that fund kind of subsidizing that energy cost for the poorer population of Europe, to have clean and abundant energy instead of rationing and all that.
Personally, I think it should go towards university funding. I think it's terrible that the EU is behind in terms of innovation, new patents. It's embarrassing that China is such a poor nation per capita and yet is leading the way.
Yeah, no, I think, as I said, I think we obviously believe that, you know, zero carbon fuel is what we're saying, but I actually think the idea of zero carbon solutions is interesting. So maybe you should pitch AI and sort of the digital tools to improve basically operational efficiency as part of the mix, and that might end up in some universities to fund research.
I have no idea. No, I mean, I can tell you what we've done with ETS proceeds from, you know, from the sectors it already applies to, which is basically we used around, in Greece, we used around 70% of that annually to support renewables, directly support them. So this, historically, that's how we approach ETS. That has, I mean, it has provided a tangible benefit in bringing down, de-risking, first of all, renewable investments, and also bringing down the cost of renewables itself. And then we spend smaller amounts of money on various other causes that we consider or are valuable, that we want to support. For example, what we call carbon leakage. Industries leaving Europe because they cannot deal with that additional cost, and it's intensive industries, they get funded from that. Or, for example, green innovation, electric vehicles, stuff like that. But that's targeted and it changes. The main amount goes towards de-risking de-risking renewable technologies, paying for them, and making sure that we can gradually introduce more and more in the system. I'm not saying it should be like that for the new proceeds coming in, but it's what we've done.
Tax cuts.
I think it's first of all, I'm not really sure that you can just do anything you want with that money.
Sure, no, but what I mean is, if you're imposing a tax on the economy that is shrinking the economy in one way, does it not make sense to mitigate that?
I'm not really familiar with the tax landscape, so I'd rather not comment. I have no idea, actually.
Okay. Other questions? Okay, let's finish off by just going through some other decarbonization approaches, just getting a quick yes or no on them, which we haven't talked about. What do people think about wind propulsion, rotor sails, and this sort of thing? I'll take that as a no.
I think they look great. I got so excited when I saw them. I ended up Googling them for ages and watching all the videos, and then I got the sustainability officer to run the numbers based on our ship's trade, and she was like, yeah, it's going to cost you a few million and you're going to save 3%. So killed my dream of having to.
Our vessels are very, very high and loaded to the stability limit. So I mean, I'm not very in favor of putting forces on top of that.
We used to have flattener rotors on some of our ships. We didn't see the benefit that we were expecting when they were working, to be honest. So I'm not so much in favor. I mean, I'm waiting to see what are the benefits of the new Cargill Mitsui developed ships and how that is going to affect efficiency, because don't forget that the wind propulsion doesn't necessarily take you from point A to point B promptly. So, you know, we need to have that in mind. So if you need 10% more voyage to save 3 or 5%, that kind of defies the purpose. So let's see how that works in the future. But we had flattener rotors, and we're not so happy with the result altogether.
What about nuclear?
I'm not really sure how those technologies apply to shipping, so I don't.
I mean, I think maybe sometime, but I think, you know, waiting for nuclear is not an option when nuclear, and we are not spending the energy on developing nuclear. But if somebody wants to go that route and try it out, I think that's for them to decide, and sometime in the future it might be.
Hydrogen?
I mean, hydrogen is, I think, the solution, right? Which includes all the green and biofuels, and which is really where you started with. Basically, scaling renewable energy is the most important part of the answer to everything about decarbonization.
I mean, how far do you think we are from hydrogen?
Me personally?
Yes. So you're better equipped to answer this question, no?
Yeah, I think obviously the other technologies we've mentioned are at a greater stage of maturity, ammonia in particular, which serves, I think, a similar function, but it's kind of technically closer to being there. I can't give you a number in terms of years. I haven't studied it enough.
We're stuck with the rotor sails and the bubbles and the...
Give you the EIA's answer, because
Yeah.
we're just another session. They basically say that it has the potential of being 5% by 2030, max.
Right.
While we wait for nuclear and while we wait for, all these things to develop in the future, let's all try to do the best we can on the existing vessels. There are 13,000 dry bulk ships right now in the water that need to be operating more efficiently, which means digitalization, installation of high-end electronic equipment, and it's going to help the ship understand itself and the office to understand the ship better. So that's number one, in my opinion. Coatings, all the other existing energy-saving devices that can make improvements up to 15 or even 20%, and that's right now. So when, we have your ammonia ships, hopefully very soon, and that becomes a prevailing technology, we're going to be fully there to support it. But in the meantime, let's make, the existing vessels, thousands of ships, more and more efficient, and we can do that. And also, most importantly, like Katerina said before, a reduction of speed and optimization of the waiting times and the cruising sailing speeds.
Yeah.
I'm very happy that I heard you before when you went into so much detail on operational efficiency. And if it's one thing we've learned in the energy sector, well, the power sector is the sector that has been decarbonized more than any other, and it will probably reach net zero before any other sector. So perhaps the most important lesson we have learned in that process is that energy efficiency, which is basically the equivalent of operational efficiency for ships, how we use the energy we have in smarter, more efficient ways, including digitalized solutions and all that, gives the best ratio of cost versus result. So it makes sense. We have a saying that the cheapest megawatt hour is the megawatt hour that is not consumed. So this is embedded in our whole approach towards decarbonization and net zero in what we call the energy efficiency first principle, which is a principle of designing systems that says that when you want to add an extra megawatt of capacity in the system, whether it's from renewables or whatever, first you have to check if with the same amount of money you can reduce the power that new capacity would have produced. So that's an exercise embedded in the whole system. We try to apply it to the extent we can at various levels, policies, even businessmen. But yes, this is fundamental in any serious attempt to decarbonize any sector, and the power sector is the proof of that concept.
Okay, well, I think we're out of time. So thank all four of you very much for coming here and for sharing your insights. This was very interesting and educational for me. And thank you to all of you and all of you at home for watching.